A student tries to solve the equation 2x equals 10. And here's what the student did. So 2x equals 10, so they subtracted 2 from each side and got the solution x equals 8. And we're asked to first of all describe any errors and then to solve the equation correctly. So if we look at this, what the student did was subtract 2 from both sides. Subtraction is the inverse operation to addition. There's no addition up here. There's multiplication up here. And then if you look at what they did, 10 minus 2 is indeed 8. But 2x minus 2, you can't actually put those two together. You can't just subtract that coefficient of the x and get it down to 1. So those are the errors that the student made in solving the equation. So let's solve the equation correctly. So here's what they did over here in blue, and here's the equation, and we'll solve it ourselves correctly. So we see that x is multiplied by 2. We want to do the inverse operation to multiplication, so we will divide. Divide the 2x by 2. To do that to the left side means we have to also do it on the right side, okay, to keep them in balance. And then 2 divided by 2 gives us a 1, so we'll end up with x equals, and 10 divided by 2 gives us 5. Now to know that we solved it correctly, we could take this value of 5 and we can plug it into the original equation of 2x equals 10 and see if we get a true statement. So we'll get 2 times 5 equals 10, or 10 equals 10. And that checks. So that tells us that this is actually the correct solution to the equation. Our student that tried to solve it on the other side could have also checked his or her answer by plugging in. What would they have gotten? Well, they would have gotten 2 times 8 equals 10, or 16 equals 10. And that's not a true statement. 16 does not equal 10. So that student could have found out by checking that his or her solution was not correct and they should go back and try again.